After having determined how to draw a sample and actually drawing a sample, the next thing you're going to want to be able to do is present it in a meaningful way. Because whether what you're looking at is qualities like eye color or length of hair or anything else you might be talking about, presenting a big clump of information, particularly a big clump of numbers, is, well, not very smart. Not very smart for the least reason because, as many of you probably know, seeing a great big pile of numbers all at once is intimidating, unclear, and most of all, unhelpful. No one really knows what you're trying to do if you just show them a page full of numerical values. They will get annoyed and stop listening to you. So, this is why we have our frequency distributions, where frequency distributions are in particular useful when we're talking about data that is numerical. If you have stuff that is more quality-based, more qualitative, like eye color, you can categorize naturally in that way. This sort of representation allows us to make categories that we can fit numbers into instead, that don't automatically fit that categorization, at least in the same sort of clean way. And you have a number, but you want something that people can more easily recognize patterns for. That's what we have this to do, where we call the groups that we fit these things into classes that are broken down by their class width, that is how wide of a range each class has to fit, and the frequency is the amount of things in each of those groups, in each of those classes that fits between the boundaries of each width. And this is a odd process making this sort of thing, where a lot of textbooks will follow a very unhelpful and backwards approach to getting the classes in terms of having a given number of them and finding the width instead of having a width that makes sense for the data and taking the number of classes you get from that. But, well, we're not going to focus too much on the construction in this class. We're more going to look at the details and interpretations, and when we do use constructions, we're going to see that there are natural patterns for things to fall into. But anyway, let's get a quick example for the types of things that we might look at when given a frequency distribution, and then we'll get an example for talking about how you might want to create one. For this, you want to construct a frequency distribution for the given data on the age of maximum yearly growth for 35 boys, where, sorry, but I'm not going to read all 35 of those numbers because it's a bit of a jumbled mess, and also, well, we're not going to get a table and interpret it first. We're going to make the table, and I misspoke a little bit earlier, but, well, we're going to see why you'd want to do this anyway. And in this case, we're not going to worry too much about making our classes because we've only got data from 10 to 18, so there's not a great deal of reason to make classes that are like from 10 to 12 or something like that. We've only got 9 of them to begin with. It's not worth the extra effort. Anyway, here we're going to make our classes where we have the age of maximum growth at 10, 11, 12, 13, 14, 15, 16, 17, and 18. And then we're going to look at the number of boys at each of those ages who grew the most within that year. So we have 1 who had their maximum growth at the age of 10, 2 at 11, 5 at 12, 7 at 13, 9 at 14, 6 at 15, 3 at 16, 1 at 17, and 1 at 18. And with this picture, we have hopefully a better understanding of the data here, because we can see with this that most had their maximum growth in 1 year between the ages of 12 and 15, with a particular peak at the age of 14, which should make sense based on how puberty works for boys. And then from there, they decreased a little bit beyond 18, although there are some, not beyond 18, excuse me, beyond 14, although there are some outliers every now and then who have later growth spurts. But, as we can see, the table gives us a cleaner picture of what's going on. So, let's get one more example here with roughly the same idea behind it, the same sort of thought of wanting to make the best picture that we can to fit the information that we have.